Hello, we're going to talk about unit conversions. This is a very important skill for the math HiSET. So first of all, let's talk about what are units. Units are something we use in everyday life. Think about the difference between $10 and 10 cents. Although both are the number 10, $10 is very different and much bigger than 10 cents. So we can think about dollars and cents as units of measurement for money. We also use units of measurement in all types of ways: money, time, weight, length, distance, and volume. Let's look at some examples. Time, we might talk about time in seconds when you're putting something in the microwave, but hours when we're thinking about planning our day. Weight might be pounds or ounces. Length, we could measure in inches or in yards. Distance, we might measure in miles. And volume can be gallons or pints. And there's a lot more. So we know that there are different units of measurement, but the question is, why would we want to convert between them? Why would you want to, for example, be able to convert seconds to hours or ounces to pounds? Well, units describe the world, but it's more helpful if they're understandable. Let's take an example of this couch. I could talk about this couch as being 152 centimeters long, or 0.00097 miles long, or 60 inches long. All of these are accurate, they're correct measurements of the couch, but none of them really make a lot of sense to me. I don't normally measure furniture in centimeters. I definitely don't measure it in miles, because who's heard of a mile-long couch? And I don't even normally measure it in inches. When I'm talking about the length of a couch, I'm probably going to say that it's 5 feet. So converting units of measurement can help you put it in understandable terms. It's important to be familiar with abbreviations for units of measurement so you can recognize what unit is being used. If you don't already know these, take a moment and pause and write them down, because writing something down is a good way to process the information and to put it into your long-term memory. So length, we could talk about length in centimeters, which would be cm, or kilometers, which would be km, meters, which is just m, or millimeters, which is mm. Although all of these look pretty similar, they're pretty different. 1 millimeter is less than an inch, but a meter is about 3 feet. So when you see M, it's good to recognize that that stands for meters, and 2 M's and M stands for millimeters, which is a much smaller distance. The same goes for all of these units of measurements. Once again, if you're not familiar with them, take a moment, pause, and write them down. Also notice that sometimes there's an S on the end and sometimes there's not. Look at the bottom of the list for time at years. Because normally we talk about multiple years, I put years in the plural, YRS. But if I just had 1 year, I might just write 1 YR. Okay, so let's talk about how to convert units of measurement. There are 2 methods. The first has a lot to do with logic, thinking about the problem, and the second is a method that is good for those of us that like to write things out. I prefer the second method, but I want to introduce you to both. So the first method is the multiply or divide rule. When going from a smaller unit to a larger unit, divide by the conversion factor. When going from a larger unit to a smaller unit, multiply by the conversion factor. Wait. What is a conversion factor? Well, a conversion factor is a reference point for how many of one unit are in another unit. So for example, there are 12 inches in 1 foot, or 3 feet in 1 yard. These are unit conversion factors that are available on the HiSET formula sheet. This is the sheet that you're going to get on your math exam, and I took this list of conversion factors directly from that sheet. So, why is it that when you go from a smaller unit to a larger unit, you divide, but going from a larger unit to a smaller unit, you multiply? Well, think of it this way. Let's say you have something on the top shelf of your pantry and it's a pretty high up distance. Well, that distance is a fixed point. That's maybe the thing we're trying to measure. Now, if you wanted to get to the top of that shelf, you might get two very short people, maybe like a couple of your kids, and have one stand on the other shoulder to reach the top of the shelf, and those two kids might be able to reach the top of the shelf. But you could also get somebody who's tall, who is within and of themselves tall enough to reach that fixed point to reach the top of the shelf. So if we think about that as units, kids as being one unit and a tall person, like a tall adult, being another unit, it takes more of the smaller unit to reach the same fixed point than it does the larger unit. So when you go from a larger unit to a smaller unit, let's say we switched out that adult for a couple of kids, we're going to multiply to get a bigger number. But if you do the opposite and go from a smaller unit to a larger unit, you'll divide. So I know that's a lot of logic. Let's just practice with a problem. I have a tree and I find out that it's 108 inches tall. I don't really understand 108 inches. I can't picture that. So I'm going to use my unit conversion to convert it. So I want to go from inches to feet. So I look at my conversion units and 1 foot is equal to 12 inches. I'm going from a smaller unit, inches, to a larger unit, feet. So I'm going to divide by that conversion factor of 12. My final answer for how tall this tree is 9 feet. Let's do an example in the opposite direction. If the length of, or the width rather, of the tree is 2 yards, and I want to find out how many feet that is, I'm once again going to go to my conversion factor. 1 yard is equal to 3 feet. And now I'm going from a larger unit to a smaller unit, so it's going to take more of them to measure the same distance. So I'm going to multiply by 3, and I'm going to get 6 feet. Okay, so that's method 1. Let's dive into method 2. So in method 2, you start with the known value, or the value you're coming from, and you multiply it by the conversion factor. Set that conversion factor up as a fraction, with the unit you want to go to on the top, or in the numerator, and the unit you're coming from on the bottom, or in the denominator. Let's use the example of 3 feet into inches. I start with the known value of 3 feet, and then I go to 12 inches over 1 foot. I get this directly from the conversion factor, and I put 12 inches on the top because that's where I want to go to, and I put 1 foot on the bottom because that's where I'm coming from. Then I can multiply 3 times 12 to get 36. That 1 on the denominator carries over, and I end up with the fraction 36 over 1. Of course, any number divided by 1 is 36 inches. Notice that I crossed feet out. The reason why is because these feet cancel out. Because if you divide any number or anything by itself, you end up with 1. So it kind of cancels out. That's why I like this method, is because I keep close track that I've gotten rid of where I'm going or gotten rid of where I'm coming from, and that I'm left with where I'm going. This is especially helpful when you have multiple steps. So let's try some examples, and I'm going to try the examples with method 2, but I'll briefly explain method 1 for each. So 3 kilometers equals how many meters? If I have 3 kilometers as my known value, and I multiply it by 1,000 meters, which is where I want to go, over 1 kilometer, then I end up with 3,000 meters. Remember, the kilometers cancel out because one is on the top and the other is on the bottom, and I'm left with meters. 3 times 1,000 equals 3,000. Over 1 is still 3,000. Now, if you're using method 1, then think about it this way. You're starting with kilometers, which is a bigger unit, and going to meters, a smaller unit. So you're going to multiply by the conversion factor, which is 1,000 meters, as we see in the conversion factor list. So 3 times 1,000 is 3,000. Let's try this one. 48 fluid ounces equals how many cups? So I start with my known value of 48 fluid ounces. I multiply by 1 cup because a cup is where I want to go, and I divide by 8 fluid ounces. Where did I get these numbers from? You're thinking to yourself, well, it's because here I see that 1 cup equals 8 fluid ounces. I want to go to cups, and I'm coming from fluid ounces. So I'll put the conversion factor as a fraction with 1 cup on the top and 8 fluid ounces on the bottom. I multiply across. 48 times 1 is 48. 8 carries over to be 8. 48 divided by 8 equals 6 cups. You might be wondering, how did I know that 48 over 8 is 6? It's because all fractions, remember, are division problems. So 48 over 8 is the same as 48 divided by 8, which of course is 6, and I end up with 6 cups. How about this one? 5 pounds to how many ounces? I start with my known value of 5 pounds, multiply that by the conversion unit of 16 ounces, and divide by 1 pound, and I get 80 ounces. Let's do a challenge problem. Most likely on the HiSET, you're not going to find simply a conversion problem, but you'll find something like this where you have feet and inches. So how do you calculate the perimeter? Well, remember, when you calculate perimeter, you're simply adding the length of each side. But I can't add 9 inches plus 3 feet plus 9 inches plus 3 feet as if they're all the same unit. Because 3 plus 9 plus 3 plus 9 is going to be a lot more feet than 3 feet and 9 inches, which is shorter than a foot. So I'm going to have to convert inches into feet. So let me convert these 9 inches to feet, and then I can add all the feet together to get my final answer. So 9 inches times 1 foot over 12, because feet is where I'm going to, and 12 inches is where I'm coming from. And then I get 9 over 12. Put that into my calculator to divide, and I get 0.75 feet. You could also simplify this fraction and calculate as a fraction. I prefer decimals personally. So then I take the 0.75 feet, add it to 0.75 feet, add 3, and I get 7.5 feet. Okay, if you're using method 1 to get from 9 inches to feet, you're going to notice, okay, I'm going from smaller to bigger. I'm going to divide by the conversion factor of 12, and you still get 9 divided by 12, and you should still get 0.5 feet. So that is converting units in 1, 2, 3. If you didn't understand that and you need to review, I encourage you to go back and watch this video, try some practice problems, and of course, give me a call if you're having any issue. Take care. Bye.